So creativity alone doesn't foster innovation, nor do abstract scientific or mathematical models. What we need is innovation-infused curriculum. And our innovators need to understand how to render those creative ideas into real-life situations. It's not an add-on. If I was a science teacher, for example, I would have a framework and a number of criteria that I need to meet. Here's for example. And if I took a project that's a solar light bulb in an energy awareness unit, we would outline the problem. Third world is unavailable to afford basic electricity. And then we would take, for example, these snap-on electronics, and we would compare the different light sources. And then we'd collect the data, what kind of light throughput came, for example, refracted through a PET bottle. And then we would evaluate the potential for real-life solving the problem. Of course, we could apply this to plant life cycles and reproduction, or negate the effects of gravity on germination. But we can use these tools in math and engineering, language and sports, and of course fine arts. We just need to get started. So we've designed a very quick start way to get started. First you choose a theme. Then you build a demo and have the kids play test it. Now, play testing is a great word. We'll actually see some live play testing here soon. But after the play testing, the kids are so enthusiastic that they're going to prototype their plan, and they're going to have the other kids give feedback, and they're going to iterate on that and build and showcase the project. So 2 recent projects we've done, I'll just show you quickly, is the Electronic Arcade Club and the Robotics and Coding Club. So the Electronic Arcade Club was inspiration from Kane's Arcade. I don't know if anybody has heard about Kane's Arcade or a global cardboard challenge, but we thought we would take this and do it just a little bit different. We're going to use Little Bits electronics, which are snapped together simple electronics, and we built a demo. Here's the kids working with it now. So every time I show this to adults, they say, boy, I wish we had that when I was in school. If you map that to a design framework, for example, you're going to have a number of criteria. So the first thing they did was they made a logical plan. They figured out how they're going to have a power supply. They're going to connect that to a switch and a servo with a chopstick. And then they're going to measure the points with some sort of LED bar graph. And then they're going to demonstrate that they have the technical skills to use these very simple tools to snap together some electronics, build some circuits in a few minutes. Then they're going to follow through on the plan. And here's actually the kids, after having played that demo, creating their own. So as you can see, there's a lot of fun going on. And then they would present the finished product. And what we learned from this is actually that children are teaching adults how to make again. And everyone's talking about the maker movement, but in fact, this is not new. We've skipped a few generations. We were doing this with the soapbox racers. We were doing it with crystal radios. And it's just the tools that have changed. So what we need, rather than a maker movement, is a maker revival. So now we're going to come to our exciting part of the program. How many of you seen the OK Go video? We're ready for our live demo, and we can cue the scratch on the screen. All right. So the Rube Goldberg live demo. Okay, yes, we have 2 very special future innovators here to help us demonstrate, and we've collaborated with them in the planning and the building, and so we're going to do a NASA rocket launch. We've got a number of things here. Miola is going to walk across our copper strips that are that's hooked up to Makey Makey. And actually, I'll just let you see it in action, and then I'll narrate through that at the end. So go ahead. Our astronaut loading into the rocket. All right. Do you want to back up a step and try again? Yeah, there we are. Okay, good. All right. And then we have the snap together electronics that's going to cue in Rob Goldberg style. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire. Okay, and of course, there we go. All right, back to the slides, please. That's great. Thanks, girls. All right, thank you. Go up. Thank you. Okay, so the ingredients, of course, you've already met the beautiful assistants who had planned and designed and built. And these are the components that we used. We had some makey-makey, some scratch programming, little bits, and we walked across the circuit, and we had programmed, Miola actually worked with me a little bit to set up the on-screen display of the virtual astronaut in a very graphical programming environment. Then we snapped together some little simple components like this that allow them to make the electronics very quickly. We kick off the ball, which then starts off the Lego Mindstorms, and we have a motion sensor which is hooked up to the Arduino that plays the countdown, and then we use a little bit of air pressure for liftoff. So the 4 special ingredients to all of that, of course, are critical thinking, communication, collaboration, and some creativity. And I just want to encourage you to open up to innovation in your classroom using the Maker toolset, and feel free to follow us on this journey. We're going to post many different links and resources that you can try in your classrooms, and not just in classrooms, of course, at home as well. This was a home project as well. So feel free to follow us on makertoolset.com. Thank you.